Good day, grade 11 learners. Welcome to today's lesson on technical maths. My name is Nyasha Chloride Gwangwaza. This lesson is brought to you by Gauteng Department of Education in collaboration with Saibono Discovery Center and broadcast to you by Pakama Research and Development. Manning the WhatsApp desk is my colleague, Mr. Mahlare. And please do send your messages through grade 11s. Our WhatsApp number is 079 578 2908. Like the previous lesson, please make sure that before we start the lesson, all of us have our calculators ready. We also have a pen and paper so that we'll be able to go through the activities together. And by the end of the lesson, all of us will have managed to get something out of the lesson. Like I have said, we're still looking at algebra, and our major topic today is logarithms. I'm sure grade 11s you have discussed with your teachers in term 1 about logarithms, and by now you also have an idea of what a logarithm is. But before we can go into the lesson, we'll just want to find out why is it that we need to know about logarithms. Well, logarithms is used widely in many areas. For instance, if we use logarithms when we're measuring the magnitude of an earthquake, we can also use it when we're looking at noise levels. For instance, you can think about the sound that is made by the dropping of a pen and compare that to the size of the noise that is made by an aeroplane that is passing by. In chemistry, we also use logarithms to find acidity or pH levels. And we also use it, especially when you're working with your financial maths, you're going to find that you're going to find logarithms very handy. There are so many other areas that you can think of where we use logarithms to make our calculations easier. That is the reason why we need to make sure that we understand what is logarithms and be able to use them. Right. When you write your final exams in grade 12, you will notice that what we really need you to do is to be able to understand what is a logarithm, as well as to solve problems using logarithms. But today's focus is mainly on making sure that we all understand what is a logarithm, that we're comfortable with it, as well as how to do the calculations. Right, the type of questions that you will be expecting to see in your papers are simplifying expressions that involve logs, solving equations, or the type that we saw in the previous lesson where we need to show or prove. I particularly like the show and prove because you already have a solution. All you need to do is to show us the steps that you will need to arrive to the solution. Like I indicated before, a logarithm is it can be defined as a power to which a number must be raised to get some other value. But some of us are already wondering what this is. But in other words, we're just trying to tell you that a logarithm is another way of writing an exponent. I believe in the last lesson when we're working with exponents, all of us got to know, if we didn't know already, what is an exponent. Right. So the first thing that we need to do is to be able to convert from one form to the other. Say, for instance, I have a to the x equal to b. When I'm changing this exponent to logarithm form, you take down the exponent, and this will be equal to the log of b to base a. Please take note, a should be a number that is positive. It can never be less than 0. Also, we cannot have a being equal to 1. And then also b, that is the number there, should also be positive. You will all get to understand why we're talking about this. Right, let us look at the first example that I have for you here. When I have 9 equal to 3 raised to the power of 2, when I'm converting this to logarithmic form, like I said before, a log is an exponent. So you take 2 will be equal to the log of the base that you already had, which is your 3. So that becomes the log of your the base of the log, and then you put down your 9 as the number. Similarly, if you have a fraction 1 over 64, as we all know, 1 divided by 64, if you write it in exponent form, is 4 raised to the power of -3. When I'm changing this to logarithms, I'm going to take the exponent, -3, then I'll say this is equal to the log of the base that you had when you were working with your exponent, and you take the number that you had as your solution. That becomes the number that you put there as your log. Right. So in other words, even if you have a fraction or a decimal as a base, the same conversion will still apply. There are other forms of expressing our logs, but since we are starting to learn grade 11s, we just need to make sure that we apply the rule that we've just learned. So if I have 1/8, we all know that 1/8 is the same as the fraction 1 divided by 2 all raised to the power of 3. When I'm changing this to logarithmic form, I take 3 and I say it's equal to the log of 1 over 8. And the base there was a half, so the half comes down as the base of your logarithm. Just the same as the decimal that we have here. 0.5 raised to the power of 5, if you check on your calculator, it gives you 0.03125. When I'm changing this to a logarithm, it becomes 5, which was your exponent, is equal to the log of 0.03125 to the base of 0.5. The reason why we're doing this grade 11s is not to confuse you, but to just make sure that you understand in life, we may need shorter forms of writing anything. So there are fancy ways in mathematics of making sure that we write our numbers. So logs is one of them. And the reason why we use them is because we need to make sure that there are some numbers that are very large or very small that we need to write down, and it will take us the whole page to write them down. So this is another shorter way of writing our numbers. Right. So today we're going to start quickly with an activity to see if you have understood how to change from an exponent form to a logarithmic form. I'm just going to give you 2 minutes to do this, grade 11s, to see if we can find the logarithmic form of these 3 questions. Welcome back, grade 11s. I hope that you had a nice activity here all of us would have finished working with it. Let us look at the solutions. Right, the first one, we had 5 raised to the power of 3 equal to 125. Your solution there is log of 125 to base 5 equal to 3. This could also be written by as 3 equal to the log of 125 to base 5. These two are equally the same. Moving on to the next one. Right, the next one, your solution, we had a half raised to the power of 5 equal to 1 over 32. When you're writing this in logarithmic form, again, you're going to take your exponent, you write it on one side of the equal sign, and this is equal to the log of 1, which was the 1 over 32, which was your solution, and you take the base of the exponent. The other way of writing this is log of 1 over 32 to base 2 equal to -5. Some of you are now wondering, how did this come about? Right, you remember when we're working with exponents, we say that if you have 1 over a raised to the power of m, this is the same as a raised to the power of a negative m. Now, if you are looking at this question, we have a similar situation. We have a half raised to the power of 5. This 1/2 raised to the power of 5 can be written as 2 raised to the power of a -5. And this is the same as 1 divided by 32. So when I'm changing it to logarithmic form, I take the exponent -5 and write it as my answer. Then I take the log with the base that we had. Now the base had changed to 2. This is the new base in the logarithm. And then this is equal to the log of 1 over 32 of base 2 equal to -5. Please don't get worried, grade 11s, when you see such expressions, because as we are working more with exponents and logs, you'll be able to see that we have got various ways of writing them. The next activity solution, we had a 0.7 raised to the power of a decimal, which is 0.5, and this is equal to 0.837. When we are writing this again in logarithmic form, we write the exponent equal to the log of the number with the base as 0.7. Hopefully, all of us got that right. Right. The next part of our activity today is to make sure that we will be able to work in the reverse. Our activity is now focusing on converting logarithms to powers. So if you check here, I have the log of 125 to the base of 5. On your calculators, if you check the answer, they will give us a 3. I hope that we all know how to use our calculators to get these solutions. If not, grade 11s, please make sure that you ask your teachers to assist you to find out how you work with the calculator to find the logs. Now, if I'm converting a log of 125 to base 5 equal to 3, this becomes, first of all, grade 11s, take the base of the log. That becomes the base of your exponent. And thereafter, you take the answer. The answer becomes the power of the 5. And then this will be equal to the number that you had sitting next to the log, which is your 125. I hope that was very easy to follow. Let us look at the next one. The next one says we have got the log of 25 to base x equal to 2. Again, first take the base of the logarithm, which is x, and the next step is to take the answer that we had there. This becomes your exponent. And then this will be equal to the number that was sitting next to your log, which is your 25. Grade 11s, this is quite simple. I don't think any of you will be in a position not to understand what's going on. Again, today we are going to make sure that we really practice on what we learn, so that when we end this lesson, all of us will be able to work with logs, as it is fun to be working with logs. There is your next activity. Again, I'm just going to give you a few minutes to work on this. But because you have practiced with the first one, I am going to give you just a minute to work through it. So grade 11s, let's have fun. Welcome back, grade 11s. I hope that we all managed to work through the 3 questions that I had given you. Right on to the solutions. The first one, we had the log of 64 to base 2 equal to 6. When we change this to logarithmic form, it becomes 2 raised to the power of 6 equal to 64. Well done. I know you all managed to get this one right. Moving on to the next one. This one, I know most of us were hesitant because most of us are not comfortable when it comes to decimals or fractions. But remember the rule. Take the base of the log, make it the base of your exponent. Take the answer, make it the exponent. And then you take the number sitting next to the log as your solution. Again, like the previous one, remember that you can change decimals to fractions and also fractions to decimals. So 0.3 when changed to a fraction becomes 3/10. And you can now change the base 0.3 to 3/10, and then you take the 4 to become your exponent. And then this will be equal to, again, the decimal 0.0081 becomes 81 divided by 10,000. I'm pretty sure that all of us know how to do this, but remember, if you have forgotten how to interchange from decimals to fractions, your calculators are always there handy to assist you. Moving on to the last one. Here we have a variable grade 11s. Please do not panic when you see letters, because most of you, I'm sure, do that when they see letters. Just make sure that you apply the rules that you have learned. The next solution is y raised to the power of 3 equal to 4/25. Similarly, like I indicated before, you can change the fraction to a decimal. So 4 divided by 25 as a decimal becomes 0.16. That is the reason why you see that our other solution, which you could have given, is y raised to the power of 3 is equal to 0.16. Most of these questions that we have dealt with so far, grade 11s, are just so that we are comfortable in interchanging from an exponent to a log. But we need to now know how we work with these logarithms to solve problems. Remember, like I said at the beginning of the lesson, today's focus is making sure that we familiarize ourselves with how to work with logarithms. You will find questions of application, especially as you move on to the next grade, but make sure that you understand all that we are doing now so that it doesn't become a difficult task when you get to the problem solving part. Before we go on to solving equations, we need to make sure that we all understand that there are laws that we can use so that our life becomes easier. Now, as you can see on this slide, we have a table which shows us the laws that relate to logarithms, but I have put them close to the laws of exponents because remember what I said before, laws of exponents are similar to the laws of logarithms because they are one form of the other. Remember, a log is an exponent. Now, the first exponential law, which we dealt with in the previous lesson, say that if you are multiplying terms with the same base, to simplify our calculation, we just write this as the same base, but we add the exponents. Now, when it comes to logarithms, the opposite applies. If I have the log of the product, I am going to simplify this or expand this to the log of m to base a. The base remains the same, but instead of multiplying, I'm now going to change the multiplication to addition. Like you see, it is the inverse or the reverse of what was happening when we're working with exponents. When I'm multiplying terms with the same base, if it comes to logarithms, I do the opposite. If I am multiplying, I change the multiplication to addition. So log of mn to base a becomes log of m to base a plus log of n to base a. The next one, when we are dividing terms with the same base, in logarithms, when dividing a term, we change the division to a subtraction. So what I want you to remember, grade 11, is that division in logarithms becomes the opposite of what was happening with exponents. I'm now going to subtract my logs. But take note, I'm not saying log of m minus n, but it's the log of m to base a minus the log of n to base a. Right, the next one, if I'm raising an exponent to an exponent, we use to multiply the exponents. When it comes to logarithms, we are going to change the law a bit. Instead of us multiplying in the exponent, we are going to multiply the exponent, that is the n, with our log. So please do be careful when you are working with this one. You need to make sure that you remember that you take your exponent, which is your n there, then you are going to multiply it with the log that you have. Right, there are other rules that we also learned with exponents. We say that if we raise any term to the power of 1, our solution is the term that we had before. Now, in logarithms, we are saying that if I'm looking for the log of a number with the same base of the number, my solution will be simply 1. Because what we're actually asking there is, what do I raise a to give me an a? So all of us know that a raised to the power of 1 gives us a. That is the reason why we're saying log of a number to the same base gives us a 1. The next rule, or the last rule that we worked with on exponents, said if I raise any term, but remember besides 0, the solution there will be equal to 1. So if I'm working with logarithms, I'm asking, what do I raise a to give me a 1? And we know that a raised to the power of 0 gives me a 1. Sometimes when we're working with logarithms, we need to make sure that we change. Remember, all of these laws, we're saying that the base has to be the same. Now, what happens if the base is not the same? Say, for instance, I have log of 27. Then I'm saying I need to divide this probably by the log of 2 to base 3. Now, as you can see, grade 11s, the bases there are not the same. But someone is already saying there is no base in the first one. Right? This is something that you may meet as we work with your questions. If the base is not given, please take note and remember that the base there will be base 10. Right, this is just a hypothetical example for you to be able to see that if you find the bases are not the same, do not panic. There is another law that can help us, which is what we have highlighted here. If I had log of m to base n, I can change this and write it with the same log. But now we need to see how we work with this so that it doesn't become hectic when we are trying to work with things that do not exist. So grade 11s, please remember before we continue, the base should not be negative. The number that you have there should not be negative. It should also not be 0 because the log of 0 to any base is undefined. You can verify this with your calculator. Just press in the log. You can choose any base that you want, and then you put 0. I'm sure that you will see that the calculator gives you error. So please take note. Always remember that you cannot find the log of 0 as it is undefined. Right, now moving on to simplifying expressions. We have an example here which is going to assist us to make sure that we familiarize ourselves with the type of questions that will be asked in our examinations. The first one says log of p to base p. If you look on the right-hand side, I've just given you a hint of which law we are supposed to use. Now, if you check the first one, if I said, if we have a log of a number and the base is the same as the number, then this simplifies to a 1. Then I'm going to add. The second one says log of 1 to base m. Again, as I have put on the right-hand side, the log of 1 to base a is equal to 0. So when I'm simplifying this, log of 1 to base m becomes a 0. So here we've already simplified our question. 1 plus 0, they just simply gives us a 1. I hope you were able to follow through this example, grade 11s. Moving on to the next one. Right, this one seems a little bit of a challenge because now some of us are wondering, how do I go about this? But don't panic. We are here to make sure that life becomes simple. That's the reason why the logarithms were introduced some time ago. So looking at the first one, remember when you are working, you need to work step by step. The first one says log of 8 to base 2. So in other words, we're asking you, to what power do I raise 2 to give me an 8? But it is not that difficult. What you can do is to make sure that you first write down the 8 as an exponent. Remember we said we can change a log to an exponent. So how do I do this? I'm going to say this is equal to the log. The base remains as 2. Now 8 as a product of factors, we all know by now with practice is 2 raised to the power of 3. So my life there is already easy or simple because now I know what power I raised 2 to give me an 8. Then I move on to the next part. I'm adding the log of 1 over 27 to base 3. Again, let me change the 1 over 27 to an exponent. This becomes log of, I'm sure most of us are already giving the answer as 3 raised to the power of negative 3. For those of us who are not able to follow, remember we said that when we are working with exponents, if I have a fraction with numerator 1, I can change that fraction to an exponent which is negative. So 1 over 27 is equal to 27 raised to the power of negative 1. And then we factorize the 27. The 27 now becomes 3 raised to the power of 3. And this will be raised to the power of negative 1. Thus giving us the solution that we've just found there as 3 raised to the power of negative 3. Now, how do I continue to simplify this problem? Remember here, grade 11s, I've just skipped there. Make sure that you do not forget to write down your base because it becomes senseless. The next step is to apply the rule that we've just learned before. If you see that we have log of a number that is the same value as your base, the solution there will simply be the exponent, because this is telling us to what power do I raise 2 to give me 2 to the power 3, and the power there is simply a 3. Then the next part is I'm going to add. Again, we have the same situation, a 3 there and a 3 there. So obviously the solution that I need there is negative 3. And then when I simplify this, my solution will be a 0. I hope that this is making sense to us slowly. Right. The next example, like I said before, we always meet different examples. At times, it is difficult for us to really say, to what power do I raise this number? Because if you check here, we have log of 27 to base 9. Now, obviously, if you try even on your calculator, the first thing you would say is probably 9 raised to the power of 1. Obviously, it's 9 and it's not a 27. You check 9 to the power of 2. 9 to the power 2 gives us a very large number. 9 to the power 2 is 81. So now how do I solve my problem? Right, to solve this problem, we are going to split log of 27 to base 9 to the form that I've written here for you, grade 11s. So that's the reason why we need to make sure that we always have our rules handy. And with practice, you will be able to do this on the snap of a finger. Right, so I'm going to write down this as log of, you take the number that becomes the term in the numerator. Then this will be divided by the log of your base. That is simply what it says here. I have decided to choose base 10 because working with base 10 is the easiest. We have been working with decimal numbers since time memorial. Even in grade 1, we all know decimal numbers. Only now do we realize that we can work with different bases. Now, the next step, remember, I said some of us will not be able to do this. Some of you are already probably taking your calculator to check what is log 27, but you really don't need a calculator. You are going to change 27 to an exponent. And what is 27 as an exponent? It's the log of 3 raised to the power of 3. And then what is 9 as an exponent? 9 as an exponent becomes 3 raised to the power of 2. Like I indicated before now, some of you saying, but now the base is not 3. What am I going to do? Right. Please don't panic. Remember, there was a law that we talked about at the beginning when we were looking at the laws of logarithms. If I have log to base a of m raised to the power of b, to simplify this, I am going to take down the exponent there and write it as b multiplied by the log of m to base a. So that's simply what we're going to do here. This is equal to 3 log of 3 divided by 2 log of 3. Now we have like terms, grade 11s. Log of 3 is the same as log of 3, so these two can divide, and your solution there becomes 3 over 2. Quite simple, eh? The last example that I'm going to give you involves more than one term. Now, there are a lot of rules that you need, or laws that you need to apply so that you'll be able to go through this question. So I am going to slowly go through them again with you so that you'll be able to tackle the questions that you will encounter. Right, the first one says log 3 plus log 27. Log 3 looks simplified enough. So how am I going to solve my problem? Remember, if one thing doesn't work, you need to use the other. The first law that we learned was when we're multiplying two terms, you add the logs. But now we need to work in reverse. Maybe it will make our lives easier. Remember, when you simplify the numerator and simplify the denominator far enough, you will be able to get your solution easier than if you had worked with them one by one. But remember, it is your choice. In this instance, I'm going to decide to combine log 3 with log 27. I can combine them because the bases are the same. Remember we said if you don't see the log at the base of the log, the base there is 10, but you don't need to write it. So in our case now, we're going to combine log 3 to log 27. And the rule says we simply multiply those numbers. So I'm going to write this as log of 3 multiplied by 27. Then this is divided by the log of 81. Remember now we're no longer using the one for addition. We need to use the one for subtraction. So this is going to be 81 divided by 9. Then this becomes log of 3 times 27. 3 times 27 there, I'm sure if you check, gives us 81. And then this is divided by the log of 81 divided by 9. 81 divided by 9 is a 9. Now this is easy because we have done it before. We are now going to simplify the log of 81 divided by the log of 9. Now how do I do it? Remember grade 11s, we said if a question appears like this, the easiest way out is to change that 81 to an exponent. So what is 81 as an exponent? I am sure with time, we will also be able to do this. But if not, remember I told you grade 11s, make sure that you make use of your calculator. Most of us know how to do this because in grade 8 and 9, I'm sure your teacher showed you how to use your calculators, or if not, how to use the manual method of changing 81 to a product of factors or writing it in exponential form. So 81 becomes 3 raised to the power of 4. And then this will be divided by log of 3 raised to the power of 2. Moving on, we are now going to bring down the exponent. This becomes 4 log of 3. Remember, it's 4 multiplied by the log of 3. Then we are going to divide this by 2 multiplied by the log of 3. Again, like our previous example, we now have log 3. So log 3 divides log 3, and then 4 divided by 2 gives us a 2. Grade 11s, please don't forget, if you are finding this challenging, our WhatsApp number is 079-578-2908. I hope that these few examples have enabled you to see what it is that we mean when we are working with logarithms. So let's have a small activity to help us understand how we simplify logs. I am going to give you 3 minutes to work on this activity. Welcome back, grade 11s. I hope that all of us managed to go through these questions and simplify them. Don't worry if you didn't manage to get through all the questions. It is your first time probably to see these questions. So with practice, all of us may be able to work through them even in a short space of time. Right, the first solution, you notice that we have log of 81 to base 27. Here the base is a bit large, but we can simplify it like I indicated before by just writing this as the log of 81 divided by the log of 27. Thereafter, we change 81 to an exponent, and we know that 81 as an exponent is 3 raised to the power of 4. Then we also change 27 to an exponent, and 27 as an exponent there is 3 raised to the power of 3. Then I'm sure you saw the funny picture that I had waiting for you on the right hand corner. It was just to remind you, grade 11s, that if you have an exponent, you can bring down the exponent and multiply it by the log. But now you already know that even if you do that, you'll end up dividing the log 3 by the log 3. So in future, if you find that you have log of numbers that have the same base, like in our instance here, our base is 3, your solution is simply the exponents that we have there dividing each other. So in our case, our solution there is 4 divided by 3. Moving on to the next one. Right, this one had 3 terms and we had to work with them one by one. The first one had log of 1000. The base is not there, but remember I told you if we do not have a base, the base there is an imaginary 10. So we change 1000 to an exponent. The base there is now a 10 for you to be able to see it. So it is now becomes log of 10 to the power of 3 to base 10. Then you move on to the next term. The next term says the log of 256 to base 16. Now this one cannot be simplified as quickly as the first one, so we need to apply those rules that we have been looking at. So the first thing that you're going to do is to divide the log of 256 by the log of 16. Then I'm pretty sure all of us are now familiar with the last one. The log of a to base a simplifies to a 1. Please take note, you do not change the signs that we have there. The positive, the addition and the subtraction sign remains in the next calculation as addition and subtraction. Because if you do this, grade 11s, you are going to end up with the wrong solution. Moving on, the log of 10 to the power of 3 to base 3 becomes 3 multiplied by log of 10 to base 10. Then the log of 256 becomes log of 2 raised to the power of 8. The log of 16 becomes log of 2 raised to the power of 4. Then we subtract 1. Again, like I indicated, this step can be skipped because if you are now familiar with logarithms, you'll notice that the solution there for this part of the expression will simply be 8 divided by 4. This 8 here divided by 4, which gives us a 2. So we now end up with 3 plus 2 minus 1. And 3 plus 2, as we all know, is 5. 5 minus 1 is 4. Hopefully, there are learners who are very excited because they got the solution right. Moving on to the next one. The next one has a SED. Remember when we're working with exponents and SEDs, we said we have rules that we also need to make sure that we apply. In this case, we have the sum of terms under the square root sign. Remember, grade 11s, we cannot split this and write the square root of log of 32 to base 2 plus the square root of log 100 plus the square root of 9. Remember, this we said does not apply when we are working with the square root. So the first thing that you need to know is we need to add everything that is under the square root sign, because the instruction there says we're supposed to add. Now, to add logs, we need to first make sure, or if we are using the laws of logarithms, we need to first make sure that the bases are the same. Now, if you check, the first term is base 2, the second one, like we indicated, is base 10. So we cannot use the law of logarithms of addition because the bases are not the same. So we need to simplify each term separately, right? So 32 will be written as an exponent, and the exponent there will be 2 raised to the power of 5. Then we're going to change log 100 to an exponent, which becomes log of 10 to the power of 2 divided by 10 to base 10. Going further, if we have the log of 2 to base 2 and there's an exponent, like I said, this becomes a 5. Then log of 10 to base 10 simply becomes a 2. Then the last term we do not need to simplify because we have no log in front of it. So we bring it down as a 9. Then we add 5, 2, and 9, and the sum of those three gives us a 16. And already we know that the square root of 16 there gives us a 4. Please take note, grade 11, the reason why we need to go through all these steps is because the instructions usually says simplify without the use of a calculator. So if you skip some of these steps, especially where we are applying the laws of logarithms, you are going to lose a lot of marks. And at times you'll find that when we are marking your solutions, we do not just give a mark for the solution. So please do take care and make sure that you go through all the steps and practice as much as possible so that you'll be able to get all the full marks, right? The next part of our presentation is solving equations. Some of you do not like hearing the word solving equations, but in life, remember, we always have challenges. So we always need to make sure that we know how to solve those problems. Like I indicated, we can use logarithms in real life, especially when it comes, for instance, when we are working with money. If I want to find how long I need to make an investment on using compound interest, you'll find that the number of years is in the exponent. So in this case, I need to find out how am I going to get those number of years. So the example that I chose here, although it is not a word problem, it is similar to the type of question that you may encounter when you're working with financial maths, compound interest, where you need to find how long you need to make an investment. So in this particular case, we have an exponent. And if you check carefully, our base there is 2. Now, if you want to find to what exponent you are going to raise 2 to give 15, it is going to be very difficult, because if we work with powers of 2, like when you're working with your binary numbers, you can already tell that you cannot get the solution 15. So how am I going to be able to go through this question? So the first thing that you would do is to make sure that you change this exponent to a logarithm. So remember what we said when we were changing from an exponent to a logarithm? I'm pretty sure all of us now remember. We first write down the exponent, and we say the exponent is equal to the log of the number. Our number there is 15, and we take the base of the exponent, which was 2. Now, how do I get the solution here? Pretty obviously, I cannot do this by head. I now need to take my calculator and check what is my solution. So on the calculator, grade 11s, I hope that you are using your calculators right now to get the solution. I'm sure that your solution there is 3,90689. It's a non-terminating decimal. Now, I'm pretty sure you understand the reason why at times we just write our numbers as logs, because it cuts out on us having to write so many digits. And because of this number that we got, the easiest way is to round it off to the nearest, or to 2 decimal places, like the instruction that we usually get on our question papers. So when I round this off to 2 decimal places, it gives me 3,91. Please do take note, grade 11s. Most of our questions, when we're answering and it is not mentioned to how many decimal places we need to round off, we need to round off to 2 decimal places. So if you do not know or are not familiar with rounding off, please make sure that you do practice rounding off. Moving on to the next example. Right, the next example has got too many terms, but please don't panic. We also have a rule that we can use that will help us in future. On the left-hand side, I have log of x plus 2 in brackets to base 2. On the right-hand side, I have log of 3x plus 2 to base 2. Now, if the bases are the same, we can apply this rule that I've just highlighted to you on the right-hand side. If the bases of the logs are the same, we simply take the numbers that we have next to the log. So x plus 2 will be equal to 3x plus 2. Pretty simple, grade 11s? Right, the next step is to now follow the rules that we learned when we were solving equations in our first episode. How do I solve these equations? We have variables on both sides, and as you learned in grade 8, when we have variables on both sides, we need to make sure that we take the like terms, put them on one side, and we put the numbers on one side. So in this instance, I am going to rearrange this equation so that the terms with x come on one side and the numbers on the other side. So by using additive inverses, I am going to end up with 3x minus x on the right-hand side. I chose to take x to the right-hand side so that I do not have a negative in front of my x. And then on the left-hand side, I added 2, and then I take 2, positive 2 to the left-hand side, and when I do this, this becomes a negative. Remember, grade 11s, we do not come from the same background. You probably have been taught different ways of solving equations or explanations in solving equations. Please do follow them, because it is very important to build up on what you have already learned. Right, now when we simplify the left-hand side, 2 minus 2 becomes a 0. Then 3x minus x becomes 2x. Now, what number do I multiply by 2 to give me a 0 is the next question. But I'm pretty sure you have been told that to solve this problem, I need to now divide both sides by 2. So when I divide by 2 on the left-hand side, I end up with just an x, and 0 divided by 2 is going to be 0. But hang on, grade 11s. When we are solving equations, please do remember that you need to check, is my solution correct? Is it true? But in our case, this was a linear equation. So obviously, if I substitute 0 there on the left-hand side, you would notice that it becomes the log of 0 plus 2 to base 2. 0 plus 2 is 2. So log of 2 to base 2, already you are telling me is equal to 1. So I'm saying there, on the left-hand side, we have, when we are checking, log of 0 plus 2 to base 2. And this becomes log of 2 to base 2. And our solution is 1. Then when we check on the right-hand side, on the right-hand side, we have log to base 2. But now remember our x is a 0. So 3 multiplied by 0 is 0. Then we add 2. Our solution there is also log of 2 to base 2. So we can confirm that the left-hand side gives us exactly what is on the right-hand side. So therefore, we now know that our solution is true. So x is equal to 0. Right, that was example 2, grade 11s. I hope that you were able to follow through. Now let us move on to another question which you may find when you are working. Right, here we have just taken logs with the same base because we do not want to complicate life in grade 11, but you will notice that we will get to complicated equations as we go on with our metric journey. Now, in the next question, we have the sum of logs with the same base. There is base 2. Here we also have base 2. Then on the right-hand side, I don't have a log, I have a number. Now, how do I work this problem? Like in any other equation, the best thing for you to do here is to first make sure that each of the sides of your equation is in simplified form. So on the left-hand side, because I'm adding logs with the same base, I am going to take my law of logarithms that I have just learned, which says that if I'm adding logs with the same base, log of m to base a plus log of n to the base a, this simply gives me the log of m multiplied by n to base a. So how am I going to simplify this? I'm going to say log of, I take the first term that I have there, which is x plus 3. Please take note, I'm taking it with the brackets. And then I multiply this by x minus 4. The base there is a 2, and then this is equal to 3. That is the first step, grade 11s, combining the sum of logs with the same base. Now, moving forward, I will notice that I cannot simplify this any further. So I am now going to change my log to an exponent. Remember, we said that we can change logs to exponents and exponents to logs for as long as it is going to assist us to get to our solution. So in my case here, I'm deciding now to move away from logs because I cannot continue. So how do I move out from logs? We're changing the log to an exponent. And remember what we said. We are going to take the base that we have here, which is your 2, and we raise it to the exponent 3. But I'm choosing to first write down the number that, or the terms that are next to the log first, instead of having to move this to the right-hand side. So I'm going to write here x plus 3 multiplied by x minus 4. This will be equal to, remember, the base of your log, and we raise it to exponent 3. Then moving forward, we are going to solve this equation by first simplifying the brackets on the left-hand side. Why? Remember, when we were solving equations, we say that if you check, we have got 2 brackets here, and these 2 brackets will end up giving us a quadratic equation. So if that is the case, we need to make sure that our quadratic equation ends up in standard form. And in standard form, we know that on the right-hand side, we're supposed to have a 0. So I am going to expand the left-hand side. So some of us use the method which we call FOIL. Some of us use blocks. Whatever your teacher taught you, grade 11s, remember that is what you need to use to make sure that you do not make mistakes. There is no harm in learning new things, but work with what you are comfortable with. So x multiplied by x gives us x squared. Then x multiplied by -4 gives us -4x. Then we're moving on to the next term. +3 multiplied by x gives us +3x. Then we're now going to multiply the last terms. +3 multiplied by -4, this gives us -12. Then on the right-hand side, 2 raised to the power of 3 gives us an 8. I'm pretty sure some of us are even working faster than I am doing here. So let us continue. X squared, we're going to add these two like terms. -4x plus 3x gives us -x. Then we subtract 12. And at the same time, I'm now going to bring the 8 to the left-hand side. This becomes -8. Then this is equal to 0. Now moving forward, this becomes x squared minus x minus 20 equal to 0. Now, I'm pretty sure you're familiar with what you learned in the first lesson. Those who are not comfortable with factorization, please make sure that you also make use of the quadratic formula. But in this particular example, I'm going to use factorization. Now, for factorization, remember, if the coefficient of x squared is 1, like in our case, I just look at the last term. The last term is 20. So we are going to look for factors of 20, which we subtract to give us a -1, because the coefficient of our x there is 1. So the factors of 20, as we all know, the factors of 20 are various. We have 1, we have 2, we have 4, we have 5, and lastly 20. Now the pair there from the factors of 20, that gives us 1. When we subtract, obviously, is 4 and 5. So I am going to now write my expression with brackets equal to 0. The first term there will be an x. The second term will be an x. And then I write my factors 4 and 5. But remember, we need a -1. So it means that the bigger term factor is supposed to be negative. So we're going to have -5. And there we have a +4. Now, to solve this equation is simple, grade 11s, because now you know that using the product rule, x plus 4 will be equal to 0, or x minus 5 will be equal to 0. So x will be equal to -4, or x equal to 5. But like I mentioned before, please make sure that you check your solutions to see if they are going to give you a correct solution. So when you quickly substitute into your expression, you are going to take your calculator and say the log of -4 plus 3 to base 2 plus the log of -4 minus 4 to base 2. And if you check on your calculator, I'm sure grade 11s, you'll be able to get the solution, which is 3. I hope you are following that with me, grade 11s. We also do the same with 5. You check log of 5 plus 3 plus the log of 5 minus 4. All this is to base 2. I'm sure if you check again this with me on the calculators, you must be able to get an answer of 3. This was quite a mouthful, grade 11s, but I hope that we are all able to follow. Right. Before we move on to the next solution, I just wanted to see if we really could confirm. Right, if you check carefully, if you substitute, let me just go back a little bit. If we substitute x equal to -4, What do we get on the calculator? I hope that you are checking with me quickly. Do we get 3? Someone is already saying, no, that doesn't give us the correct solution. So that is the reason why grade 11s, I am saying, please do make sure that when you are checking your, when you are done with solving your equation, you check your solution to make sure that the answer that you get there is going to give you the answer that you have on the right-hand side. Right now, it is your chance, grade 11s, to make sure that you also follow the same rules that we have been working with to solve the following set of equations. Right, so there is your 3 questions equal to 2. So we want to find out what is the value of x. What exponent do I raise 0, 2 to give me a 2? So pretty obviously, I cannot find it without having to use my logarithms. So the first thing that I'm going to do is change this exponent to a log, and it becomes x is equal to the log of the number there, which is 2 to base 0, 2, which was the base of your exponent. Now, after you've done this, I'm pretty sure you took out your You can choose which side you want to put the number, but in this instance, I chose to put it on the right-hand side. Now, this becomes the base, which is your 2 raised to the power of -1, and this will be equal to 3 minus x. Now, to solve this equation, you all can see we now have a linear equation. So, linear equations are very simple to solve because all you need to do is to make sure that you have the variable on one side and the numbers on the other side. So in our instance, we're now going to add x to both sides, and then when we add x to both sides, we're going to end up with x on the right hand side because x plus half gives us x. Then on the right hand side, we are going to remain or keep the number 3, but because we want numbers on one side, we're going to subtract a half on both sides. So our right hand side becomes 3 minus a half, and 3 minus a half gives us 2 and a half. Remember what we said, we need to check if our solution is indeed a solution. So you going to substitute 2 and a half in place of x on the left hand side. So on the left hand side, we're going to have log of 3 minus 2 and a half to base 2. Right? So grade 11s, I hope you took out your calculator to confirm this. Log of 3 minus 2 and a half to base 2 gives us -1. I'm pretty sure you can confirm this with me. Right, the last question. The last question was a sum of logs on the left hand side. So the first thing that you would do is to make sure that you combine that sum. And you remember the law or the rule that we used before when we are adding logs with the same base. Please take note there, I haven't complicated things as yet. We have the same base, which is 2. So you combine this by multiplying the numbers or the terms x and x plus 2. So when we are multiplying, remember we need to introduce brackets, so that is the reason why we're writing it as log of x multiplied by x plus 2 to base 2. And this will be equal to the number 3 because 3 there is already simplified. Now, moving further, I am now going to remove the logs. When I remove the logs, I am simply changing the log to an exponent. And how do I do this? I'm pretty sure by now we know how to do this. We take the base and raise it to the exponent. So on the right hand side there you see I have 2 raised to the power of 3. And then this is equal to the number or the terms that I had next to the log. I have kept them on the left hand side because it is easier if I do that. Right. Then the next part is, also if you check carefully, this 2 will end up giving us x squared. This is a quadratic equation again. So I am going to multiply x by x, which gives me x squared. Remember, we are now multiplying a binomial by a monomial there. So please don't forget the distributive law that we have been learning. We need to multiply x by x first, which gives us x squared. Then we multiply x by positive 2. This gives us positive 2x. So on the left hand side, we now have x squared plus 2x equal to 8. And then, after I have done this, because it's a quadratic equation, I make sure that I bring all terms to one side. So this becomes x squared plus 2x minus 8 equal to 0. Again, like I indicated, you use the method that you're comfortable with, either using the quadratic formula or you can also use factorization. In this case, I used factorization because the factors of 8 that give me 2 when I subtract are 4 and 2. So my brackets become x plus 4 multiplied by x minus 2 equal to 0. Now when I solve this equation, x plus 4 equal to 0 gives me x equal to negative 4. And then x minus 2 equal to 0 gives me x equal to 2. Now if you check the solutions again with the calculator, remember you always need to do this when you're solving equations with logs. If you substitute negative 4, let us take log of x to base 2. If I substitute x equal to negative 4, this becomes log of negative 4 to base 2. But remember, we said when we are working with logs, our number that's sitting next to the log, they cannot be negative. And you can verify this with the calculator, because if you say log of negative 4 to base 2, I'm sure on the calculator there it says error. So make sure that when you're working, the number there should not be negative. Also, the other thing that we mentioned is the base of your log should also not be negative. So in this case, we are going to reject x equal to negative 4 because we cannot find the log of a negative number. It is undefined. That's why you see that I have written my conclusion there saying that the only solution that we have there is x is equal to 2. Well done to those who got all these questions correct. You are on your way to getting a distinction at the end of your matric. Right, the next question that I have, remember we said there were 3 types of questions that we have when we are working with our logarithms. The first one I said is just simplifying. Then we moved on to equations. The next part is a proof or a short type of question. So my question there says we need to show that the log of 64 to base x plus the log of 4 to base x minus the log of 8 to base x, all divided by the log of 1024 to base x equal to a half. Some of us are already panicking. They see big numbers there. They also see a base that is no longer a a number or an or a real number. So please don't panic, grade 11s. Just remember the laws that we have been working with will help make our calculations easier. So the best option to take is first combine the terms in the numerator. Why am I combining them? It is because I notice that all of them has the same base, which is an x. Since all of them have base x, I can apply those laws of logarithms that we have learnt. So the first law says if I'm adding logs with the same base, I am going to combine them simply by multiplying those numbers that you see next to the logs. So it's 64 multiplied by 4. This is to base x. Then after that we have a minus, meaning that we apply the second rule. But I know some of us may find it confusing to work with all this at the same time. So it is allowed for you to work with one at a time. So here I am going to leave my subtract log of 8 to base x as it is. And then I also leave log of 1024 to base x as it is. But remember, grade 11s, when a question says that show that or prove, you work with one side at a time. So in my case, I have chosen the left hand side because the right hand side seems simplified enough. So that is the reason why I chose to work with the left hand side. So continuing, when we multiply 6 by 24, let's check with our calculator. 6 multiplied by 24, what we get. I'm sure that you got your answer as 144. So we have log of 144 to base x minus the log of 8 to base x, and this is divided by the log of 1024 to base x. I know this is making our calculation a little bit longer, but this ensures that we do not make mistakes when we are working with our questions. Now the next part is I'm going to use that law that says if I'm subtracting terms with the same base, I am going to simply divide the numbers that are next to the log. So this becomes log of 144 divided by 8 to base x, and in my denominator I still have a log of 1024 to base x. The reason why I haven't changed any of this is so that my calculations do not become complicated. Now if we simplify this on the calculator again, 144 divided by 8, I hope you are following it with me, grade 11s, you are going to end up with, sorry, now because of space I'm going to move on to the right hand side, grade 11s. This will be equal to the log of 32 to base x divided by the log of 1024 to base x. And now we are back to that question where we have logs that are being divided, and these logs have the same base. So how am I going to continue? I'm pretty sure you have said, let's change that 32 to an exponent. So this now becomes log to base of 2 raised to the power of 5 to base x divided by log of, again, 1024 can be written as an exponent, and there your base is going to be base 2, fortunately. So this becomes log of 2 raised to the power of 10 to base x. And then when I simplify this, remember, because now the logs are the same, here the bases are also the same. What did we say, grade 11s? I'm pretty sure all of us are shouting there. We can just take those exponents and divide them. So this becomes 5 divided by 10. And we all know that 5 divided by 10 is the same as saying a half. But for those of us who cannot move from this step here that I have directly to 5 divided by 10, remember there was a friend of ours that reminded us that if I have log of a number to a base and the number there is raised to an exponent, I am going to take down the exponent and then I multiply it by the log of the number with the same base. So in our case, we are saying that I would have taken down the 5 and multiplied it by the log of 2 to base x. I'm pretty sure that all of us will be able to follow through questions that look like this. The key there, grade 11s, is that whenever you get a question, do not panic. Just try and make sure that you follow all the rules, or try to figure out which rule am I going to use to get to my solution. Right, unfortunately, grade 11s, because of time, we are not able to move on to word problems where we actually find out how do I use this in real life. But like I mentioned before, we will be using this when we are applying in our various fields. As we are technical learners, we work probably with electrical, or we are working with welding. There are questions there where you'll find that you will need to apply logarithms to find your solutions. And remember, these exponents and logs work with either very small numbers or very large numbers. So if you are able to follow these through, you will definitely be a good engineer one day. That's all the time that we had for you today, grade 11s. Thank you for watching this lesson. Please remember to sanitize, wear your mask, maintain social distance, and keep safe. And please do keep practicing and ensure that you work with your teachers so that we get those good results that we need to achieve. I would like to thank you, grade 11s, for joining us today. We will meet each other in the next episodes. Thank you. Goodbye.